name's Beck, and I'm sure you all know me. I'm going to talk about DNA replication, learning as much as you know on DNA, like replication, its function, or what it goes for. Go ahead and write in the next column what you want to know and what you're wondering. Just take a couple minutes to do this. Anything that you have in your no column? Jamie?
The nucleotides are thymine, guanine, cytosine, and adenine.
You sure? Okay. What else? Keenan?
The double helix structure of two phosphorus spines that have nitrogenous bases connected using bonds that aren't ionic. They're covalent bonds with hydrogen bonds connecting the bases to each other.
Okay. Anyone else? I'm sure you guys should know more. That's going to be a big thing for our lesson today. Catherine?
They have 3, 5, 5, and 5 prime in, and they go opposite.
It's negatively charged.
Kyle?
It's found in the nuclei.
One more. Yeah.
Adenine binds with thymine, guanine binds with cytosine.
Adding with.
A's and T's go together.
Alright, so you guys we need to know that the nitrogenous bases, we need to know their names and what they bind with so that we can do this next activity. So, A is, what?
There was a question.
T?
No, it was a question.
G and C?
Guanine, cytosine.
Alright, so which one binds with which again?
A, T, G, and T.
Okay. So, for activity, everyone's going to get these little strands of pipe cleaners, and I have nucleotides in the back, and you're going to have to go and find a match. The color that the phosphorus and the hydroxyl are doesn't have to match the one that from the strand that you have. And as soon as you finish that, I'm going to pass a worksheet that just goes over what we just talked about.
So does every person get one or every pair?
Every person should get one. Hey, I have extra. Alright, so go ahead and move around and go find, oh wait, you need to know the colors. Okay, so the sparkly red pipe cleaner is the adenine, the gold one is the thymine, and then guanine is green and cytosine is brown. So go ahead and go look for your nucleotides.
Oh, I can't connect. I need a red. Red!
There are no more gold ones?
I don't think so.
Well, I got half of them.
So does anyone want to tape theirs to the paper?
Yes, please.
Sure.
Are there not enough nucleotides?
No.
Really? How many do we have too much of?
You need one tape per group.
Yeah, okay. Anybody need tape?
I already gave it away.
Okay, never mind.
Okay, Gabby.
Sorry,
wait,
he
here,
gave
wait,
it
wait.
away already.
This. Show off my smarts. That's how it matches up.
Yes.
Anyone remember how many bonds are between an adenine and a thymine?
I go 2.
2. And then so what about guanine and cytosine?
3. You got them all in the test.
I guess you learned your lesson. Okay, so as we reviewed before, DNA is a double helix, and a strand of DNA has a 5' end and a 3' end from a phosphate group and a hydroxyl group, respectively. And when they're together, the strands of DNA are anti-parallel, which means that on the one side will have a 5' end and a 3' end, and the other side will have a 3' end and a 5' end. So yep, I can talk. So you can have a 5' end and a 3' end, and a 5' end here and a 3' end here. Okay. So now DNA replication. Okay. Is everyone done? Yes. So how does DNA replicate? Anyone remember?
You actually want to do it.
How
The whole
about
thing, 'cause I
you
feel like that's
say
difficult.
one part?
Okay, so DNA helicase unzips the DNA and breaks the hydrogen bond.
Okay. Anyone else? Any other ideas? Okay, if you don't know, because we'll go over it. Catherine.
Semi-conservative, so one stays the same and the other one is brand new.
Nice job. Okay. So what goes into the replication of DNA? So we're just gonna watch a quick video.
Yes.
When helicase unwinds a segment of the DNA and breaks the hydrogen bonds between the two complementary strands of DNA. DNA polymerase can only add new nucleotides to a free 3' end of a growing chain. Synthesis of one strand of the DNA, called the leading strand, proceeds continuously in the 5' to 3' direction. Synthesis of the complementary strand, called the lagging strand, is more complex. DNA polymerase can add new deoxyribonucleotides only to a free 3' OH. To provide a free 3' OH starting point on the lagging strand, RNA primase attaches to the DNA and
The top left one, like I don't really know, just the one directly under the word DNA, that's the leading strand.
Do you want to come fill it in?
Sure.
So you can go ahead and fill these in as we discussed. So that, all right. So in the leading strand, the leading strand is synthesized continuously because the 3' hydroxyl is free, which means that the RNA can just put, or the DNA primase can just put an RNA, a little strand of RNA onto it, and just the polymerase will continue to replicate the DNA without having to stop to find a free 3' hydroxyl. Okay, so does anyone else have a guess as to what? It's okay. So that's the helicase. What does the helicase do? Unzip. Okay. What happens after the DNA gets unzipped by the helicase? What's needed to keep the DNA?
RNA primers.
Huh?
RNA primers.
Yes, but what, Nathan?
It's some sort of protein, I forget what they're called, but some sort of protein to keep the DNA from snapping back together.
So, single-stranded binding proteins.
There we go.
So, right here. Okay. Anyone have a guess as to what these little things? Sarah, what is it? Okay, what's this? These little things are on each strand. This. And so the polymerase is responsible for synthesizing the DNA, and so it'll pull the nucleotides out from that are floating around in the cell and put them into the strand. And when that happens, it takes out two of the phosphates that are attached to the nucleotide. Just kind of like what you did with your little strands of DNA. So this is the ligase. It'll ligate the two Okazaki fragments together to create a single strand. And this is the daughter strand, this is the new strand. So if this is the daughter strand, the blue is the daughter strand, what's the yellow? Son strand.
The mother.
Okay. So that's the parent strand, or the original strand of DNA. Alright, so there's something vital missing on this diagram. Can you tell me what it is? What's missing?
Something with RNAs.
Yeah, RNA primer.
The nucleotides are missing too, but something that's needed to start the DNA. The synthesis of DNA. Primers. So, okay. So for that question, you're missing DNA. You're missing DNA primase. So if you can, maybe draw on the diagram like where a little primer would be. Maybe down here, or maybe down here. So just draw where you think a primer would be.